All right, so today we are going to look at lesson 4-6. We're going to use the quadratic formula to solve some quadratics. So we've actually had four things that we've used to solve a quadratic. So the first thing was solving a quadratic by graphing. And I can't solve every quadratic by graphing because if it doesn't cross the x-axis at a nice, perfect integer point, you just kind of have to guess. So then we learned how to solve quadratics by factoring, and not every quadratic is factorable. And so then this week we learned how to solve quadratics by completing the square, which is not always a pleasant way to, not a pleasant method to use. It doesn't always work out great. Sometimes it has fractions and it can just get real ugly. Well, today we're going to look at the fourth method for solving a quadratic, which is using the quadratic formula right here. And so, move this to where I can write on it. So you are expected to know the entire quadratic formula. All of this is what you're responsible for. These are the procedures we're going to use these are the procedures we're going to follow when using the quadratic formula. But first and foremost, let's remember the song. So there is a song that goes to Pop Goes the Weasel that you can sing to help you remember this. So here we go. X is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if you continually sing that to yourself correctly and write down the quadratic formula each and every time you do a problem, you are more likely to know it. And so these are the procedures that we're going to follow here. You're going to first have to write the equation in standard form. Remember, this is standard form, ax squared plus bx plus c equals 0, so we have to have 0 on one side. Almost every method that we've used has required us to have 0 on one side, with the exception of completing the square. Once you have it in standard form, then you can identify what values are a, b, and c, and those again are just the coefficients or the constant. There should be no x attached to a, b, and c. And they're going to substitute these values into the quadratic formula and then simplify the fraction and the radical as needed. So again, I'm not going to do all the problems that are on these notes because that would take forever. So I'm going to do a problem, you're going to do a problem. One of the things that I'm going to discuss now, which I usually wait until after I've gone through several problems, but the way the videos work, I won't be able to come back to this page. So the other important part of this formula is right under here, what's underneath that square root sign. And what's underneath the square root sign is known as the discriminant. So I'm going to put the information for the discriminant up here. And the discriminant is important because it helps us determine how many solutions we should be looking for. And it's also important that you find the discriminant correctly. So the discriminant is just b squared minus 4ac. You will not take the square root of it. I understand that it's underneath the square root here, but if I ask you for the value of the discriminant, I just want what's underneath here. Don't go and take the square root. So here's what we're going to find. So when we find the discriminant, you're going to have one of three cases. So either b squared minus 4ac is going to be greater than 0, and the kinds of numbers that are greater than 0 would be a positive value. You're going to find that that's going to give you 2 real roots. In other words, 2 places at which the graph will cross the x-axis. Then you will also, or b squared minus 4ac could also exactly equal 0. If I take the square root of 0, it's 0. And so if I take anything and add 0 to it, or take anything and subtract 0 from it, I will get the same value. So when the value under the radical is equal to 0, you will find that you will have 1 real root. And then the only other situation you can have with a discriminant is if b squared minus 4ac is less than 0, values that are less than 0 would be a negative number. And so if I take the square root of a negative number, we're going to have to use I, because remember, you cannot take the square root of a negative number, so that negative will come out in front of the radical as an I, because I represents the square root of negative 1. So you will have no real roots, or I will accept the answer of 2 imaginary roots. So let's go ahead and do a couple of problems. So I'm going to blow these up really large. So I'm going to do number 1, and you are going to do number 2. So the first thing that we need to do per our procedures above is make sure that one side is set equal to 0, which it is. So I don't have to move anything. So, and this is all in the correct order. Squared term, x term, constant. So now I can identify what A, B, and C are. So A is equal to 1. Remember, if there's no number in front of the squared term, it's understood to be 1. B is equal to 2, and C is equal to negative 63. Then I'm going to write my equation. So remember, this is a way to irritate your parents. Sorry, parents who are listening. But at least your child is doing some work and learning. So x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I can sing much faster than I can write. All right, and so I always suggest that you rewrite your formula as a template. So I'm going to remove all of the variables a, b, c, and just put in substitution parentheses. So I haven't done any math yet. I'm just preparing everything to do my math. All right, so then we're going to plug in our values. So b is going to go here, and so our b is 2. So 2 goes here and here. And then next is a. So a is going to go here, and a is going to go here. So I'm going to put a 1 in for here and here. And then finally, the only one left is our c. So our c is negative 63. Squeeze it in there. And we're ready to go. So x is going to equal, the opposite of 2 is negative 2 plus or minus the square root of. Now you got a calculator. Let your calculator do the work, especially if you're terrible at integers and multiplication division. So if you put this in your calculator exactly as you see it without the square roots, because we don't know that this is a perfect square underneath here, and so if you do that and you get a decimal, then you know you didn't have to have a perfect square. So ignore the square root. You're putting exactly this in with all of those parentheses in the calculator. If you put it in correctly, you should end up with 256, all divided by 2 times 1 is 2. So then if you take 256 and find the square root of it, you will find that it actually is a perfect square. So you get negative 2 plus or minus 16, which is the square root of 256, all divided by 2. There is no radical in your problem, so you can actually perform this math. So the two answers that you're going to get, I'm going to break this apart. One answer is going to be negative 2 plus 16 divided by 2. And the other answer is going to be negative 2 minus 16 divided by 2. So negative 2 plus 16 is 14. Divided by 2 is 7. So here's one answer. And then negative 2 minus 16 is negative 18. Divided by 2 is negative 9. There is your second answer. Now note that the value of our discriminant was 256, a positive value. And do you see that I got 2 real roots, 2 answers? That means that our parabola will cross the x-axis at positive 7 and at negative 9. Okay, so what I would like you to do is pause the video, and I want you to complete number 2 on your own, and then restart the video and check your work. Watch your signs. you are going to get 2 fraction answers. So just let your calculator reduce those fractions. Remember, your friend with a fraction is the command math enter enter, and it will convert any decimal to its proper fraction form as long as it can be written as a fraction. All right, so pause the video and go forth. Okay, so I do have one side set equal to 0, so I can identify that my A is 6, my B is equal to -11, and my C is equal to -10. So you have a lot of negatives, so I want you to watch your signs. So my formula is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Write your template. And then I'm going to plug in my values. So B is -11, less in your head, more on paper, kill a tree. -11, because that's B also. Then A is 6, C is -10, and down below A is 6. So I get X equals, the opposite of -11 is +11, plus or minus the square root. And again, if I put this in my calculator exactly as I see it, I will get 361 all over 12. So if you, and I would start out, 361 is a weird number. I really don't know what goes into it off the top of my head. So I would start off by putting 361 in my calculator and taking the square root just to see, for chuckle's sake, is it a perfect square? And lo and behold, your calculator will spit out a beautiful number of 19. So the square root of 361 is indeed 19, and it's still divided by 2. So we can figure out that answer by splitting up the work. So we've got 11 plus 19 divided by 12, and 11 minus 19 divided by 12. So on this one I get 30 divided by 12, which reduces to 5/2. So there is one answer. And again, you're putting that 30 divided by 12 enter into your calculator. It's going to give you a decimal. And then you're going to hit math enter enter, and it will reduce it to 5/2 for you. Then 11 minus 19 is -8 divided by 12. That reduces to -2/3. Once again, let me point out that the value of your discriminant was a positive value, and you got 2 real roots. All right, so let's go ahead and move down to number 3. Now, how is number 3 and 4 different from 1 and 2? You can see that neither one of them are solved for 0. So that's going to be your first goal, is to solve this equation for 0. So I want to move this one over to this side and have everything on this side and 0 over here. That'd be the least amount of work. So I'm going to subtract 1. I don't have a like term to line 1 up with, nor do I have room to kind of put it off to the side. So don't add it to the 2x. So you get -x squared plus 2x, and then minus the 1, and then it will equal 0. Now I can identify what my A, B, and C are. So A is -1 because it's a -x squared, so the coefficient is -1. B is equal to +2. And C is equal to -1. Now if you happen to be missing your x term, then your B is going to be 0. If you're missing your constant, then your C is going to be -1. Or if you're missing your constant, your C will be 0. All right, so let's go ahead and write my equation. So X is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. It's kind of catchy. Write your template. So the only work that I've done so far is to move that -1 over and identify my A, B, and C. Now put them in your template. So B is +2, +2, and then A is -1, C is -1 also, and A down here is -1. So x equals, the opposite of 2 is -2 plus or minus the square root of. Now here, if I put this in my calculator exactly as I see it, I'm going to get 4 minus 4, which is 0. All divided by 2 times -1 is -2. Now, notice that the value of the discriminant is 0, so according to what we discussed earlier, I should get 1 real root. Watch what happens. So the square root of 0 is 0, so I get -2 plus or minus 0 divided by -2. I can split that into two answers, -2 plus 0 divided by -2 and -2 minus 0 divided by -2. Well, -2 plus 0 is -2 divided by -2 is +1. Here, -2 minus 0 is again -2, still divided by -2 is 1. So you really only get one solution, x equals 1. Because both solutions are the same, you only have to write it once. This is called a double root because you've got two roots that are the same, giving you x equals 1. Now what does this mean? How can a parabola only cross the x-axis in one place? I will show you. So let's say that this is my xy axis. Now I know that it's crossing the x-axis at +1 right there. That's my root. But remember, we know a lot of things about this. If I look at this in standard form, isn't C also my y-intercept? My y-intercept is 0C. So if my y-intercept is -1, I'm going to plot a point here at -1 on the y-axis. And don't forget, I have an axis of symmetry going through that vertex. So I can reflect this point 1 unit away on the other side because this is 1 unit. So I can go 1 unit on the other side. And I get a third point here at 2, -1. Whoops, let me put that in blue. And so given those 3 points, I can now sketch the graph of this parabola, and that is how it can only touch the x-axis once. Note that A is negative, so my parabola opens down as expected. It only touches the x-axis there at +1. Okay, so I want you to pause the video and I want you to complete your work for number 4, but a couple of things first. So first and foremost, you of course are going to have to move all of this to this side. Line up like terms, only add things that are like terms. So get one side equal to 0. One of your answers is going to be a fraction and the other answer will not be a fraction. So pause the video, watch your signs, sing your song. Good luck. Okay, so I want to start by moving, and then I'm going to add the 15 as well. I really don't have a like term to add it to, so I'm just going to add it down here. But they're not really alike, so don't add them. My highest degree term is -2x squared. Then next comes the x's. So 3x and a -4x is a -1x, so feel free to write -1x so you can see the coefficient. And then plus that 15 is equal to 0. So now you can identify A, B, and C. A is equal to -2, B is equal to -1, and C is +15. So for your formula, x is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I think I've got myself a new calling in life. I'm going to make millions just singing the Quadratic Formula song. If only that were the case. Okay, so plug in your numbers where they belong. So my b is -1, so I have a -1. And a -1 here. And then my A is -2, there's a lot of negatives. My C is 15, and my a is -2. So watch all those signs. So x is, the opposite of -1 is +1, plus or minus the square root of. So put this in the calculator exactly as you see it, making sure you use parentheses, especially here. So when you do that, hopefully you got 121, 121 underneath the radical, all over -2 times +2 is -4. 121 is a perfect square, so 1 plus or minus 11 is the square root of 121 over -4. So split your answer up. 1 plus 11 divided by -4 equals, and 1 minus 11 divided by -4. So 1 plus 11 is 12, divided by -4 is -3. There's your one solution there. And then 1 minus 11 is -10, divided by a -4. Two negatives make a positive, and then this will reduce to 5/2. So again, look at that discriminant. It's positive, so I should have 2 real roots. Okay, so we are going to skip all the way to questions 11 and 12. Now, if you want to do more problems, you can always look at the notes that are posted online and grade your answers from there. All right, so we are going to skip all the way to the bottom. And actually, I'm going to do 12 for you and with you, and then you're going to do 11 on your own because 12 is harder. So the same process. We are going to start with moving everything from this side over here where the x squared term is. So I'm going to subtract a 4x and subtract a 5. I have no x term to subtract that 4x from. So it really is not a like term to that x squared, so don't combine those. So I'm going to end up with 5x squared minus the 4x. Those are not like terms, but these are. So 9 minus 5 is a +4 equals 0. So then identify a equals 5, b equals -4, and c equals +4. In your formula, x is the opposite of b plus or minus the square root of b squared minus 4ac, all over 2a. So how many times have I sung the song while taking notes? If you don't know the song by the time you're done with your notes, you have not been singing it with me. Okay, so b is a -4, so we have a -4 there. And then it's -4 here as well. And then a is 5, c is 4, and a is 5. So I get x equals, the opposite of -4 is a +4, plus or minus the square root of. If you put this in your calculator exactly as you see it, you will get -64 underneath the radical. All over 2 times 5 is 10. Now the value of your discriminant is negative, so I should get an answer with an I in it. I should get 2 imaginary roots or no real roots. So this parabola will not cross the x-axis at all. So what to do? So we get 4 plus or minus this negative right here is going to come out in front of the radical as an I. So I've got an I in front, and then the square root of 64 right here that says a perfect square, it's going to come out in front of the I as an 8. And there's nothing left underneath the radical because 64 is a perfect square, and so all of that's over 10. Now remember, having an I in your answer counts as a radical, but we still have to be able to reduce. This is a whole fraction. So to help you reduce the fraction, Since both of these are over 10, I can split this into two fractions. I can put the 4 over 10 and the 8i over 10, and that will help me reduce it. So that's what I'm going to do. So I've got 4 over 10 plus or minus 8i over 10. So then all you have to do if you are struggling with reducing this, you just put in your calculator 4 divided by 10, enter. It's going to give you a decimal, and then hit math, enter, enter, and it will reduce the fraction for you, and it will look like this. 2/5, and then plus or minus, and then just put the 8/10 in. You can't put the I into your calculator. It won't know what to do with it. So put the 8/10 in, hit enter, you'll get a decimal, 0.8, and then hit math, enter, enter, and it will reduce this to 4i over 5. So you can leave this as your answer, or since they were both over 5, we can combine the numerator and put it over 5. And this is the preferred way to write your answer, but I'm perfectly happy if you leave it as we just did on the left. But this is the answer I would love for you to be able to get to. Okay, so notice that we did indeed get 2, because we have a plus minus 2 imaginary answers, no real roots. So what I would like you to do is try number 11 on your own. So pause the video and then restart it. So I can identify what A, B, and C are. So A is equal to -3, B is equal to 8, and C is -7. This is the last time. Enjoy it while you can. The opposite of B plus or minus the square root of B squared minus 4AC all over 2A. Bonus points for how many times I sang that song. Actually, I'll just give you candy. You just quietly come tell me. Okay, so then my B is 8, so that goes here and here, and my A is -3, and my C is -7, squeeze it in there, and my A is -3. So I get X equals the opposite of 8, which is -8, plus or minus the square root, and all of this under the radical turns out to be a -20, all divided by -6. So I am going to, this -20 is not a perfect square, so you're going to have to simplify that radical. So I'm going to take the negative out from the 20, and the 20 will prime factor into 2 2s and a 5, all divided by -6. So this negative comes out in front as an I, and then you're going to circle a pair of 2s, and they're going to come out as a 2, and you'll have a 5 left underneath. So right now we have -8 plus or minus 2i square root of 5. All of that is over -6. Please make sure you put your I in front of the radical, not behind. So then I'm going to split this and this into two fractions, both over -6. So I get -8 over -6 plus or minus 2i radical 5 over -6. So the first part's easy enough. You're going to put -8 divided by -6, enter into your calculator. Going to get a decimal and hit math, enter, enter, and it will reduce it for you to 4/3. Positive 4/3. You got two negatives, make a positive. Then plus or minus. All you're going to put in your calculator is the 2 and the -6. The I and the rad 5 you can't put in your calculator. So 2 divided by -6, enter, is going to give you a decimal. Then math, enter, enter, is going to give you -1/3. What I would like you to do is push this negative up to the numerator. When you have a negative in a fraction, it can be in the denominator, or you can move it to the numerator, or it can just hang out to the side. Because I want it to match the fact that this is a +3, I'm going to change this negative and push it up there. So when it reduces, 2/6 reduces to 1/3, I'm going to make the top and negative 1 times I radical 5 all over positive 3. Now you don't have to write the negative 1. Typically I would just write a negative I rad 5, but I wanted you to see what happened. The 2 6 changed into 1/3, and this negative I just bumped up here. So remember, a positive divided by a negative is just a negative. A negative divided by a positive is still a negative, so it doesn't matter where you put that negative. So I will accept this as an answer, or because they're both over 3, I can combine them and say plus or minus negative I, that's your negative 1I, radical 5 all over 3. Now, just as a last kind of hurrah, if you happen to look at the notes will tell you that this is a positive I, because technically 4 plus a negative I is a 4 minus I. 4 minus a negative I is a 4 plus I. So this negative kind of becomes a moot point, and you could have just written 4 plus or minus I rad 5. But I am thrilled and happy if you got this far. So it's good for me. All right, so do your homework. Remember to ask me questions, come in early for help, text me, anything. All right, good luck.